Have you ever took a close look up in the sky? With your own eyes, you see something flyable. It has a square-shaped basket with people in there, and it is being held by an envelope made of nylon and polyester. Today, we are going to talk about this documentary on hot air balloons and their main dynamics. Hot air balloons operate based on a simple scientific principle. Warmer air rises in cooler air. Here's how they achieve this magical flight. The actual balloon, known as the envelope, is made of reinforced fabric, usually ripstop nylon or ripstop polyester. It's the colorful part that holds the air. When you launch a hot air balloon, you unwrap the envelope and lay it along the ground. Using two large inflatable fans, you inflate it with cold air. Once inflated, you tie it to the burner and basket. The burner is the heart of the hot air balloon. It heats the air inside the envelope. It has different types of valves, such as the quiet burner, fire 2, the trigger valve, and the blast valve. Those are the four main valves. The burner runs on propane gas and it fires upward from burners. Basically, the maximum liters on propane for hot air balloons can usually be up to 50 liters. As the burner heats the air, it expands, making the air inside the envelope less dense than the surrounding air. The basket is where passengers and the pilot stand. Some baskets can hold up to 30 people, mostly for balloons that are over 270,000 cubic feet. It basically hangs beneath the envelope and provides stability during flight. Hot air balloons float due to buoyancy, the same principle that allows boats to float on water. Here's how it works. Basically, everyone knows that a boat floats because the water beneath it supports its weight. The pressure of the water pushing upward balances the boat's weight pulling downward. Similarly, a hot air balloon floats because the heated air inside the envelope is less dense than the surrounding air. The open bottom of the balloon allows air to enter and escape, adjusting the density. When the burner heats the air, it expands, causing some air to escape. This reduced density makes the balloon rise. After inflating the envelope with cold air, you use the burners to heat the air until it's hot enough to lift the balloon off the ground. Once buoyant, the balloon gently rises. Burners can basically go up to 4 burners. Basically, there can be 1 burner, 2 burners, 3 burners, 4 burners. Most hot air balloons usually use 2 or 1 burner, but for the 3 and 4 burners, they are mostly for huge ride balloons. The pilot controls the altitude by adjusting the burner intensity. To descend, the pilot cools the air by reducing burner output. To ascend, more heat is applied. Wind direction determines the balloon's horizontal movement. Hot air balloons have such a rich history. It started with the Montgolfier brothers in 1783 after when they pioneered human flight with their practical hot air balloons over 120 years before the Wright brothers' engine-powered flight. Today, hot air balloons offer a serene and magical way to explore the skies, providing breathtaking views and unforgettable experiences. A hot air balloon is inflated partially with cold air from a gasoline-powered fan. Before the propane burners are used for final inflation, during the manufacturing process, the material is cut into panels and sewn together, along with structural load tapes that carry the weight of the gondola or basket. The envelope needs to be made from material that is both strong and lightweight. Most modern hot air balloons use nylon, which can withstand the heat and tension involved in a hot air balloon flight. The nylon is cut into panels and sewed together by skilled sewers. An individual panel is known as a gore, and a balloon can be made up from 4 to 24 gores. The top of the envelope often has a crown ring, a metal hoop about 1 foot in diameter. The crown ring is attached to the envelope with tapes. The top of the balloon has a vent that lets air escape to make the balloon descend. The rope attached to that is known as a vent line. The most common type of vent is known as a parachute vent. When a control line is pulled, the vent opens. Releasing the line causes the hot air inside the balloon to close the vent. Most recreational flight balloons have the typical balloon shape, but the envelope can be made of any shape without significantly affecting its aerodynamic qualities. Novel balloons used for advertising have unusual shapes. There is 3 types of balloon envelopes. There is a racer, a round, and the most popular one, a special shape. Racers are mostly used in competition. Round can be also used in competition, but is mostly used for flying free-for-all. And special shapes can also be racers. The basket needs to be strong enough to hold both the passengers and the pilot. Their size is dependent on the canopy size and the number of passengers it will carry. Most baskets are made from natural willow and cane. Although some baskets are made from modern synthetic materials, willow cane is still used because wicker baskets made from these materials are resilient, lightweight, and easy to keep clean. They also look romantic. Traditional wicker balloon baskets that fly in Britain are mainly made by hand skilled British craftspeople. The burner is powered by propane gas and heats the air inside the balloon that causes it to rise. Many balloons use one burner, but some have 2 so that the pilot can use one or more at a time to vary the intensity of heat. Most hot air balloons are made with old technology, but one recent addition to the equipment of the balloon is GPS tracking devices carried in the balloon so that the ground crew can track the speed and direction of the balloon. Pilots also carry instruments to measure altitude, the rate of climb, and air temperature. Hot air balloons need to be kept clean and dry to prevent mildew and mold when packing. The burners have to be regularly inspected every year and the fuel leans kept clear. Many hot air balloons are made in Britain by specialist hot air balloon makers, such as Cameron Balloons of Bristol that has been making balloons since 1971. The company claims to be the largest manufacturer of hot air balloons in the world. Hot air balloons carry small 20 to 40 gallon liquid propane tanks that allow for an hour to an hour and a half long flight. Burning 30 gallons per hour, hydrogen and helium are no longer used for hot air balloon rides but are also used in gas balloons, which no longer carry passengers but fly solo. Gas balloons differ from hot air balloons due to the fact that they are enclosed with a lifting gas and that they remain a dull gray. Rather than an aesthetic color splash, this recreational and scientific form of aviation has been around since 1783. Gas balloon pilots, called aeronauts, traveled far and wide prior to the invention of airplanes. The Smithsonian Magazine notes that in 1862, aeronauts James Glacier and Henry Coxwell traveled higher than Everest's 29,029-foot peak, up to 37,000 feet into the atmosphere. Although gas balloons are not specifically used for this function in the 21st century, these are still used in the realm of research, flying without pilots or passengers. Today, weather balloons are miniature gas, balloons that utilize a lifting gas to soar, providing data for upcoming forecasts. NASA uses massive gas balloons for space and Earth exploration by way of super-pressured, zero-pressure balloons. These balloons, according to NASA, are large enough to fit 195 Goodyear blimps inside of them. Super-pressure balloons look like pumpkins and can fly 120,000 feet high for up to 100 days. While zero-pressure balloons operate from shorter ascents ranging anywhere between a couple of hours to 55 days, NASA balloons can help take measurements, collect data, and even explore new planets in the galaxy. The balloon program has hopes to expand to exploration in the atmospheres of Mars and Venus with the help of lifting gases. So what are lifting gases and how do they work? Both helium and hydrogen are considered lifting gases because they are lighter than air. In fact, they are so light that when these gases are released into the atmosphere, they disappear into space. This is one of the reasons why helium capture is so important, as helium is a non-renewable resource and its supply is limited on Earth. It turns out that helium can lift just more than party balloons. The Labor Day Liftoff in Colorado Springs, the Snowmass Balloon Festival in Aspen, the Sandy Balloon Festival in Salt Lake City, and several other festivals in the region backdropping mountain ranges and dreamy desert terrains are the perfect summer cap-off. Each year, 70 hot air balloons, give or take, depart from Memorial Park in Colorado Springs at the Labor Day Liftoff for a sunrise and a sunset spectacle. The nighttime rides showcase balloons glow like lanterns across the backdrop of Pikes Peak. Less than a month prior, in Salt Lake City, on August 12th and 13th, hot air balloons will rise with the sun to introduce a day filled with all kinds of outdoor activities, a 5K, concerts, and a market of local goods. You can be certain that gas distributors for hot air balloons are doing behind-the-scenes work to make these events a success as hot air balloon pilots prepare the propane for liftoff. In case of a hot air balloon, upon ignition of the fuel, the temperature of the air inside the balloon is increased. As a result, the volume of the gas increases in accordance with Charlie's law. When the air inside the balloon expands, it becomes less dense and provides the lift for the hot air balloon. Ideal weather for hot air balloon flight consists of clear skies with good visibility, light winds on the surface, and moderate winds aloft, less than 25 knots at 9,000 feet above sea level. Flights take place at sunrise and approximately 2 hours prior to sunset. Hot air balloons are not able to fly during the middle of the day due to thermal activity, which makes the air unstable. The weather has to be visible for hot air balloons to fly. Weather refers to the short-term conditions of the lower atmosphere, including factors like precipitation, temperature, humidity, wind speed, and atmospheric pressure. It's what you experience when you step outside on any given day. Meteorologists analyze data from satellites, weather stations, and buoys to predict weather conditions over the upcoming days or weeks. Weather influences various aspects of human activity, from sailors and pilots planning for storms to farmers timing their crop planting and firefighters preparing for potential forest fires. On the other hand, climate describes atmospheric changes over longer periods, usually 30 years or more. It's not about daily frictions, but rather the overall trend. For example, even though we experience cold spells in Alberta, the long-term climate trend may still be warming. Climate change is a significant concern, with 97% of scientists agreeing that global warming is really and largely caused by human activity. When it comes to flying, pilots must consider weather conditions carefully. Here are some key points. 1. Thunderstorms. Thunderstorms are not to be messed with. They can cause severe turbulence due to rapidly changing winds within the storm cell. While flying through a thunderstorm won't crash an aircraft, it can seriously discomfort passengers. Strong winds, downdrafts, and wind shear are all factors to consider. 2. Night operations. During the day, storms are easier to spot, but at night, or when shrouded by clouds, pilots rely on weather radar. Night operations have specific rules, including instrument rating, requirements, and equipment considerations. 3. Flight duration. Most large commercial jets can fly 8 to 16 hours non-stop, depending on the model and conditions. Some ultra-long-haul flights can even go to over 20 hours with extra fuel takes. Remember, weather and climate impact aviation safety, and pilots make informed decisions based on these factors. So next time you board a plane, appreciate the intricate dance between the atmosphere and flight. The envelope is usually treated with a polyurethane coating to reduce porosity, and in the coating is an ultraviolet inhibitor to help the fabric withstand the rays of the sun. The top cap or crown of the balloon may be designed in one of two ways. The standard top features a circular deflation port that is closed off by a circular panel, which is held sealed during flight by a flexible hook and loop closure. A deflation port line, usually called the rip line and colored red, extends from the top to the basket and is pulled by the pilot upon landing to effect an instantaneous deflation of the envelope. Pull on the line and the hook and loop closure comes open and the hot air rushes out. The parachute top also features an opening in the crown along with a similar circular panel to fill the opening. In this case, the panel is rigged up with lines, as the name suggests, exactly like a parachute. It is used both for effecting a complete deflation of the envelope after landing, and also during flight to vent a limited amount of hot air, as it means for controlling vertical ascent or descent. After landing, the pilot pulls on the top line of the parachute top and holds it open for as long as he can until the envelope has been deflated. Balloons built with the standard deflation port also feature an opening in the side known as the maneuvering vent. Also instantly sealed, like the deflation port, by hook and loop closure, this vent is operated by a rope called the maneuvering vent line, which extends from the vent to the basket. The pilot pulls the line, causing the side vent to open and allowing the hot air to escape to stop a rate of ascent or indicate a rate of descent. Once the line is released, the vent automatically recloses. A skirt, it has a couple names, a skirt, a mouth, an apron, a nomex, or throat, is connected to the bottom section of the envelope with peelable tabs and helps create a stovepipe effect when the burner system is running, channeling the warm air into the balloon and improving fuel efficiency, especially on windy days by protecting the burner from the wind. Attached to the inside of the balloon envelope near the top or crown are temperature indicators known as telltales. These telltales are white when installed but turn black if the air in the envelope exceeds a certain temperature. This permits the pilot to tell at a glance when his balloon may need repair. We also mentioned earlier that the cubic capacity of an envelope dictates how many people can be carried aloft safely in a balloon. However, this capacity may be adjusted upward or downward depending on other factors, principally air temperature and altitude. The key is to determine the maximum safe gross weight that can be carried by the balloon on a given day. All balloons are provided with FAA certified curves for estimating temperature, limited gross weight, and also other stuff. These curves show gross weight in pounds versus air temperature in degrees Fahrenheit for operation at various pressure altitudes, usually sea level at 5,000 feet, 10,000 feet, and 15,000 feet. Currently, open-air passenger vessels for balloons are made either of wicker or aluminum and fiberglass. A rigid tubular framework extends from the basket upward where it attaches to the 24 stainless steel cable suspended from the envelope. This rigid framework actually serves three purposes. 1, it helps protect passengers. 2, it supports the burner system, which is installed overhead at the top of the basket. And 3, thanks to the mechanical fulcrum effect, it provides the basket with stability and less of a tendency to tip over upon landing. Baskets normally come in square or rectangular shapes. Triangular shapes are also available and on special order. One can obtain completely enclosed gondolas or deluxe baskets with built-in banquet seats and insulated champagne holders. As a minimum, there must be room on board for securing the necessary fuel tanks and flight instruments. Wicker is the classic or traditional look in a basket, but it is actually not just nostalgia that makes it a popular material, even though it costs more than aluminum fiberglass varieties. The strong and resilient rattan that is woven around a tubular aluminum frame happens to provide an excellent shock absorber during less than perfect landings. The aluminum and fiberglass baskets are quite strong and lighter than wicker. Although they do not have as much give on impact, these baskets are often used for commercial ventures where more rugged conditions are the rule. If the envelope and the basket are the most visible parts of the balloon, our third major component, the burner system, is the motive force, for it produces the heated air which the pilot uses to lift off and to control his vessel's up and down motions once aloft. Normally the burner or burners point directly into the center of the balloon envelope. There is a pilot light very much like the kind found on ordinary gas stoves, and this assures rapid access to heat whenever necessary. There is also a blast valve allowing the pilot to adjust the rate at which fuel flows from the tanks. To draw fuel into the burner, the pilot simply pulls the trigger on his blast valve. The liquid propane gas is carried under pressure from the fuel tank to the burner, where it is set on fire by the pilot light. A pressure gauge on the burner tells what this pressure is. The propane is transferred from tanks in the basket through a flexible hose to the burner system. This fuel goes through the coils on the burner, which vaporizes the liquid gas. Then the pilot light ignites the vapor, sending a 6 to 8 foot flame into the envelope, making a loud whooshing sound. and adding heat at the rate of 12 million BTUs, British thermal units per hour. The BTU is defined as the quantity of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. To give a better idea of the tremendous output of a burner system in a hot air balloon, one burner produces at a rate per hour that would be enough to heat 123 bedroom homes comfortably. Propane, the fuel used almost exclusively in hot air ballooning, has the additional advantage of being readily available and quite inexpensive in today's energy-scarce world. Also called liquefied petroleum gas, or LPG, it is by product of the petroleum manufacturing process. Propane is odorless. Incidentally, so as a safety measure, refineries introduced an ingredient called mercaptan into the gas. Mercaptan has a strong Swedish skin, which makes gas leaks readily detectable. The propane is stored in fuel tanks, either 10-gallon aluminum or 20-gallon stainless steel tanks. The advantage of the more expensive stainless steel tank is that it is lighter, so then you can carry more fuel with less tank weight. There are two ways of heating air inside the envelope. One is by triggering the blast valve, as mentioned, which when wide open can add heat at the rate of 12 million British thermal units per hour. Intermittent blasts during flight enable the pilot to maintain a standard temperature in the balloon, and a standard temperature generally provides a standard altitude for that flight. The second method of adding heat to the envelope is by using the cruise or metering valve. By monitoring the exact flow of propane to the burner, you can then maintain a steady output from the burner, which will provide a standard temperature. This would enable you to maintain a straight and level flight without having to touch the blast valve that often. It's as close as you come to flying on automatic pilot in a hot air balloon. We've covered the three basic components of the hot air balloon: envelope, basket, and burner system. But there are other items of equipment that pilots need and sometimes use frequently. Some of these items are required by the FAA, some recommended, and some optional in the same sense that mud flaps and FM radios are optional on new cars. Here are the required equipment. Altimeter. This tells you how high you are above the ground, normally giving you readings in feet above sea level, and can be adjusted to the local ground elevation where the ascent is taking place. Variometer. This is basically a rate of climb meter and lets you know first of all if you are moving up or down. That may sound a little ridiculous, but at altitudes of 1,000 feet or more, where visual references are few and far between, it is often quite difficult to judge such basic facts of life as whether you are on the way up or on the way down. The variometer also measures the vertical speed of the balloon in feet per minute or second. Pyrometer, an electrical sensor installed near the top or crown of the envelope, sends information to this meter in the basket. It tells the temperature of the air in that area. As with RPMs in an automobile, there is a red line, not to exceed in terms of an envelope temperature, beyond which you are risking damaging fabric strength. The pyrometer helps you monitor this important factor. Fuel gauge. This shows how much propane is left in the tanks on board, and because fuel supply is important to a safe and sane balloon flight, such gauges should be as reliable and visible as possible. Sparker. This gadget comes in handy for quickly reigniting a pilot light that has inadvertently gone out. Most pilots carry 2 sparkers plus a cigarette lighter and a pack of dry matches. To be on safe sides, sparkers are also used by weeders and by campers for starting up Coleman lanterns, so they are also readily available. Headgear. Headgear is not recommended as much, and you don't have to wear it in a balloon, but protective hats or helmets are vital safeguards in the event of a fast or bouncy landing. As with lifeboats on a ship, there could be enough to board for all occupants. We are now going to talk about some recommended equipment. Protective clothing. There is no point in totally ignoring the remote, but real chances for injury involved in ballooning. In that spirit, let's note a few simple precautions to incorporate in your standard garb for the sport. The pilot should wear some eye-protecting device goggles or simply a pair of sunglasses during the inflation stage. This will shield his eyes from any backlash of heat from an unexpected gust of wind blowing flames from the burner toward him instead of toward the envelope, and conceivably save a nice set of eyebrows. Pilot and crew should wear heavy-duty gloves as protection from the heat of the burner and its flames, and also from possible rope burns. Pilot and crew should wear long-sleeve shirts and long pants. Again, to protect themselves from the heat and flame of the burner system during inflation, cotton or fire-retardant materials are preferred, not nylon and polyester. Pilot, crew, and passengers should wear sturdy boots or high shoes so everyone is more comfortable in the rough or slippery terrain once might conceivably land in. Fire extinguisher. It should be one of the types of useful in combating propane fuel fires and carried not only in the chase vehicle but on board balloon. The 2A10BC is the type often recommended. First aid kit. It should include silver compound medications for burns and, like the fire extinguisher, be carried both on board and in the chase vehicle. Balloon logbook. The pilot records the date, place, and other pertinent details of every one of his flights in the given balloon. We're now going to talk about optional equipment. An electric blast valve. This is a push-button valve control that can be operated from anywhere in the basket. Electronic ignition. Similar to above, this operates off a battery and keeps the pilot light going. Compass. Until recently, FAA regulations required balloonists to carry a magnetic compass on board, but this device plays no practical role, at least not on short flights. On long flights in unfamiliar countries, it does give you an idea of the exact direction in which you are gradually getting lost. Last but not least, a communication system. On short flights, there is no particular need to be in touch with Houston control. Aviation radios and transponders are useful on board for long flights at high altitudes, and radios are required to be carried if you are flying through any airport traffic control zone. In conclusion, most hot air balloons use propane in the burner to heat air. The propane is highly compressed in the cylinders and flow to the burner in a liquid form. When the pilot starts the burner up, the propane flows to it and is ignited by a pilot light. We are now going to take a little short break here as I have a presentation for you guys on a firefly basket and a little short candlestick. Okay. This is a firefly basket with a T3 burner. This is a basket for a 56,000 cubic feet balloon called Turn It Up. As you see here, this cord, this is the main burner. This goes to the fire tube, and then this one goes up to the pilot light, which is just right in there. And yeah.
Manually operated gas burner valves designed to control gas flow to a burner. These valves are typically actuated every time the appliance or burner is used. A Delta C rating indicates that the valve is suitable for use on commercial cooking equipment. These top burner valves are shown in closed position with stem flat in same quadrant as inlet. Valves with stem flats in other quadrants are also available. Turn counterclockwise, 90 degrees to each successive position indicated in function column. LA designates an adjustable low. Stem diameter is 34. Customer to specify stem dimensions E, F, L, and whether slit on the end of the stem, either parallel or perpendicular to the flat, is required. Dimension E in whole inches, tenths, hundredths is substituted for E in model number. To specify the hood orifice size, off-on valve with an 8 to 27 orifice thread, dimension E of 1.88, 1 and 7/8 inches, and hood with number 42.0935 diameter. Fuel flow is controlled by an on-off valve called the blast or main valve. The burner is available in single, double, triple, and quad variants. A minimum of 2 blast valves and 2 fuel supplies are always fitted. In 1975, we also discontinued the toggle valve design commonly used in other balloon burners for the much simpler trigger valve design. The toggle valve design requires periodic maintenance to assure that propane leakage does not occur. The ball valve, on the other hand, is maintenance-free and does not contain the O-rings found in the toggle valve design. Also, no lubrication is required for the life of the ball valve, as required in the other valve designs. Another reason we discontinued the toggle valve was because of its poor fuel flow characteristics. This valve design runs the propane in an up, around, and down flow pattern, making for considerable restrictions in the valve. The ball valve, on the other hand, has a large diameter flow port that runs straight through the valve body. This gives the ball valve unbelievable advantages in flow characteristics. Avian's burner design is further complemented by its fuel system design. A burner can perform only as well as its fuel system. Avian's fuel system is engineered to allow maximum fuel to the burner. We did this by first custom designing our 15-gallon stainless steel fuel tanks. Although most stainless steel fuel tanks look the same on the outside, as you review our design, you will notice we chose to install the fuel valve, bleeder valve, and pressure relief valve separately. Tons of people feel it is better to have 3 separate valves to handle 3 separate functions. Some other tanks on the market utilize a single valve to do all 3 functions. We use the mandrel type fittings because more fuel is allowed to flow through these fittings than a non-mandrel fitting. This type of design is used throughout the fuel hose system to assure there are fewer restrictions in the system. These design features, along with our trouble-free vapor pilot lights, have given the burner designs a distinctive edge in high-performance burner technology.
Have you ever seen a hot air balloon touch the water, like land in the water while it's flying? If you have, then let me tell you what that's called. In hot air ballooning, we have this little fun thing we do where we touch the water, and it's called a splash and dash. But if you do it too hard, where you get wet, like the water goes up to your knees, and that's called a splunk and dunk. So we're gonna do a little experiment with this tennis ball here, and I am going to throw it up onto the ceiling, and if it hits hard like that, then that means that was a splunk and dunk. If it hits a little, like, kind of average, then that means that it was a little too hard for a splash and dash. And if it hits the ceiling lightly, that was a splash and dash. Let's try it. Okay. Okay, here is the first attempt. Let's throw it up. Okay, it did not touch the ceiling at all. Oh my god, that was pretty perfect. If you saw that, it literally just hit it lightly and then rolled down back and then just hit the table, like, yeah. Alright, I'm gonna try this 3 more times. Okay. Yeah, it did not hit it at all. I am pretty secure about this tennis ball, but if you want, you can try this at home. Alright, let's see this. Alright, that was a little too hard. That was barely a splunk and dunk, so yeah. Okay, I'm gonna try it one more time. Okay, that was also light. So, we got 2 splash and dashes, 2 nothing, and 1 splunk and dunk. So, yeah. If you want to try this at home, you absolutely can. And ballooning rules. Back to you. Have you ever seen hot air balloons do this cool, fun looking competition before? It is in most hot air balloon competitions and it is one of the most common balloon tasks out there. But if you have seen that before, let me tell you what it's called. This type of task is called the Hare and Hounds task. The Hare and Hounds, or as it used to be named in the USA, the Fox and Hounds, it is a relatively simple task where all you have to do is follow a balloon that lands before you and then drop your marker on the target upwind of the balloon once it has landed. As it is simple and it is not often used, the most common time this task is now set is when the winds are light with no predictable direction in evening flight. Occasionally, a double hare and hounds will be set where the hare balloon touches down after the first set of time, and the rest of the balloons are the hounds. Some of the crew disembarked with one target, which is then displayed while the hare balloon takes off again and flies on for the second part. Through in the natural world, the hare will do all in its power to escape the following hounds. This is not the case in this task. The pilot of the hair balloon will try to ensure that most computers will pass over the hair once landed, otherwise it becomes a wasted task. Balloon competitions take several days. Commonly, 2 flights are designated for one day, and each flight consists of a series of tasks selected by the director before takeoff. After assessing the weather conditions and other relevant factors, therefore, competition flights are not aimed at achieving fastest time, maximum distance, or altitude as in other sports. They require pilots to apply their skills of maneuvering their balloons over a set of course. They include goals, targets, scoring areas, time and distance limits, which a pilot has to take into consideration to prove his flight planning, anticipation, and managing ballooning skills in the given weather conditions. Good results in competition tasks are achieved by using a combination of good flight planning, choosing the appropriate takeoff site, appreciation of winds at various altitudes, tactics to choose and determine the goal, and good balloon managing and a bit of luck. By lifting and descending the balloon, the pilot tries to catch the right wind current that takes him to his goal or target. Balloons do not land on the target itself, but it is up to the pilot to drop markers, small sandbags with streamers attached, as close to the target as possible. The result is the distance between the marker and the center of the target. The pilot whose marker lands closest to the target is awarded the highest score. There is no direct mechanical means of controlling lateral movement for a hot air balloon, but a change in direction can be achieved by utilizing the wind currents at hand. Sometimes, at different altitudes, the wind will vary in general directions. By climbing or descending into these layers of the air, the pilot is able to maneuver the balloon onto a preferred line of travel. Pilots must accurately gauge the speed, direction, and strength of the winds before the flight, and be able to predict changes during the flight. Special awareness and perception are the key to success once you are airborne. The pilots must have a good understanding of the competition area based on the rules of the competition. They have to be aware of their position in the air at every single moment, the position of their target in the area, where other balloons are and where they are heading, and what areas they should avoid regarding the flight regulations or competition rules. The basis for orientation is a topographic map that the pilot has traditionally in a hard copy, but most pilots are also making a use of navigation software, satellite navigation, GPSs, and tablets. There is only one person in command of the hot air balloons, the balloon meister or the hare, but teamwork is an indispensable part of the competition. The ground crew helps pilot prepare for the flight and after the flight is completed. They help with instruments and equipment needed for the flight. They follow the balloon, giving the pilot accurate information about weather conditions, which could be crucial for success. The communication runs via radio or mobile phone. Quite often at international competitions, the computers from the same country help each other exchange information during the flight, prepare the tactics and flights together, and thus try to gain some advantage over the other computers. The only way to control a hot air balloon is by operating the burner and vent. Operating the burner seems very easy, but it requires concentration and precision, so any nervousness or emotional tension resulting in overcontrol has an immediate effect on the flight. Pilots must control their emotions so they can demonstrate their abilities with an even temperament at all times. The preparation and accumulated flying experience are therefore of crucial importance for the pilots. The winner of each task will get 1,000 points. The others get less, calculated proportionally according to their achievement in the task. The winner is the pilot who gathers the most points during the competition. It is important that pilots do not fail by trying to score too many points in one particular task instead of achieving a good overall average, and that requires good tactics, adapting, and anticipation skills.
The most common question asked of a balloon pilot is, how do you steer a hot air balloon, and where are we going to land? The answer is not always as simple as giving a specific location. The comic answer is, on the ground. I have been known to answer well over a few thousand times with, I like to think of a hot air balloon flight as the old-fashioned Sunday drive. You never know where you are going, how long it would take to get there, or what you would see along the way. In the back seat, we yelled to Dad, "Are we there yet?" In a balloon, we don't want it to end. The best answer is, we have several landing sites we use. where the landowner has graciously given us permission to land and access with our crew for retrieval of the passengers and equipment. The method we will use to steer is to choose a variety of altitudes over the flight duration to steer to a predetermined safe landing site. What makes a good landing site? From the pilot's perspective, a good landing site is a location with good access from the air, using wind conditions to navigate safely into without jeopardizing passengers, crops, or animals. Large enough to fly into in variable wind conditions, with safe terrain features for passengers, crew, and vehicle to move about, and importantly, a place where our landing is welcomed and does not interfere with landowners' privacy or fear of risk. That's a lot to consider. Hot air balloons have no built-in mechanism for steering or propulsion. It uses the speed and direction in which the wind travels to move. However, that does not mean that pilots let the balloon amble anywhere. At different altitudes, the wind speed and direction are different. Pilots place the balloon at different altitudes at certain times in the flight to change the direction of the flight path. Operation of a hot air balloon is done by the pilot controlling the temperature and volume of the balloon, adding heat to go up, maintain level flight, and slowing the balloon's descent rate. Changing the volume of the balloon by opening a large vent in the top center of the balloon allows the pilot the ability to start a decent valve off excess heat and make the balloon heavier for landing. Prior to flight, a pilot gets information about the direction of surface winds at different altitudes from weather sites, such as nearby airports, local home weather stations, reporting online, and weather service forecasts. At the launch site, a pilot lets go small helium balloons for an actual observation of current wind condition over the intended flight area. Routinely, a pilot understands the local flying conditions and airflow in the area being flown to plan a flight path to a variety of good landing sites. Using personal observed conditions and understanding the overall weather patterns during the flight period, before launch, pilots determine the best case scenario of winds, altitudes, and terrain of the intended flight to navigate to good landing areas. Pilots will regularly cancel a flight when suitable wind speeds and directions are not in place for a safe flight path to good landing sites. It is always a difficult decision to cancel a flight, especially when passengers are present and the excitement of the upcoming flight is high. But cancellation is always in the best interest of the pilot, passengers, crew, and landowners when a safe flight plan cannot be determined in advance of launch. Hot air balloons are clearly not designed for long distance or specific air travel. A pilot cannot deviate from the actual wind speed and direction except to terminate the flight and land. Should the directions or speeds become undesirable or head in the direction of unsuitable areas for safe landing, the best decision is to land when able and where it's safe to do so. In this opportunity, the pilot may or may not have advanced permission to land or access the property, so it becomes necessary to locate the owner and obtain permission. The precautionary landing decision sometimes means meeting a new landowner, clearly and respectfully explaining the precautionary need for landing and pack-up, and understanding any concerns the landowner may have for their property, animals, crops, and privacy. In most cases, the landowners are very welcoming, and permission is quickly given. This is not always the case, and the occasional landowner can be unhappy with the interruption of privacy and concern for animals and property obstacles. Hot air ballooning has been determined by the NTSB, National Transportation Safety Administration, as the safest way of manned travel. This is due largely in part by the safe decision-making process of the pilot and crew. Ballooning is a fair weather sport and totally dependent on suitable weather conditions for safe and enjoyable flight. The intent of a hot air balloon flight is to enjoy the serene and peaceful feeling you get when flying man's oldest and most primitive form of flight.
Oh, hey there, guys. I just want to say thank you guys so much for watching this documentary on hot air balloon dynamics and facts. Yeah, that's all I have to say about the documentary, but before we end this documentary, I just want to say that in a month and a half, the Heritage International Balloon Festival is starting, and it is from September 25th to September 29th. So, it is in High River, obviously, at the Heritage Hotel and Convention Center. And this year, it's going to be a very awesome year because I am designing the shirts for Heritage Inn and like the yearly Heritage Inn shirts. So if you want to come down to High River and see us fly, you absolutely can. I believe we're going to have over 30 balloons there because last year we had 29. And as we only had 2 flights in for that festival, and we had 1 pre-festival flight, and yeah. So I just want to say all of that stuff, and I just want to say thank you for watching the documentary, and make sure to watch our content on Wyndham Balloons, and even on Stuff You, and thank you for watching the documentary. We will see you in the next video.